In this demo, we're going to look at how you can extend an agent using contextual memory. This is done using the AIContextProvider class in the Microsoft Agent Framework. Here, we're looking at the accompanying blog that will cover this demo. The blog covers why you might want to give your agent memory, how the AIContextProvider class works, the events that are available, and it details the example of the code that we're about to look at. A function tool is also defined for our IronMind AI personal trainer agent. That's what we're looking at here in this blog. We also talk about how you can wire the whole thing up as well as the chat loop. For now, we'll dive into Visual Studio and we'll see all of this in action. So here we are back in Visual Studio, and if I open up the Solution Explorer so we can see which classes we have available, we can see that we have our agent, a memory component and a model, as well as the program.cs. If we look at the client details model, what we want to do is give our agent the capability to persist the name, the current weight, and the desired weight that a person would like to hit. To give more context in this demo, we are working with a personal trainer agent, and we're going to extend this agent to allow it to send and persist memory. And to implement a memory component, you do that by implementing your particular class. So we've got one here called client details memory. If we scroll up to the top here, we can see it's just a regular .NET class that inherits from an AI context provider. The AI context provider belongs to the Microsoft Agent Framework. We'll close the Solution Explorer for the moment, and we can see in the constructor here we pass an instance of the chat client, the serialized state of an object, as well as some serializer options. And here we take the serialized state and deserialize it to a client details model. So just for some extra context, the AI Context Provider class lets you subscribe to several events. The first one that we're looking at here is the invoked async method. And this is what happens when the LLM and your agent have been invoked. And we send over instructions, and that's what we can see here down at lines 46 to 55. Okay, between lines 36 and 43, what we have here is some debugging information. We've got that to illustrate how the flow of events occur whilst we interact with our agent, and in a few moments we'll see this in action. One thing to point out is that the invoked async method is called after an agent had received a response from your underlying inference service, such as OpenAI. And what it lets you do is inspect the request and response messages and then update the state of the AI context provider. Like I'd mentioned a few moments ago, we output some messages to the debug window in lines 36 and 42. We've got some instructions for the LLM between lines 50 and 55 that reference our client details model and how to extract those. And then down here between lines 66 and 69, we take the information and add it to the state. There is another method called invoking async, and this method is called just before the agent invokes the inference service. And what that lets you do is provide some additional context to the agent. And what happens is the context gets merged with the agent's existing context. And what this means within the context of this demo is we want to ensure that we capture the person's name, their current weight, and their desired weight. And then we pass those instructions in lines 102 to 105. One thing that I did notice was that I had to introduce a helper method called sanitize value. And the reason for that was because the LLM and the agent framework didn't always extract and map the values that were being passed backwards and forwards, despite setting the instructions. So that's just one important thing to call out here. And down here we have a method to override the serialization. Now, this only gets called when you want to serialize the thread. Situations where you might want to do that are saving the memory to a database or a flat file, and then loading it back in at some point and injecting it into a conversation. So that's an overview of the client details memory components. Just to recap, we have our constructor where we serialize the object. We intercept a method called invoke async that you can override, which gets called after the agent has received a response from your inference service. That lets you inspect request and response messages. And there is a method called invoking async, and that gets called just before your agent invokes the inference service. So now that we've covered the memory component, we'll jump out into our agent. And our personal trainer agent has one function tool, which is to get the time to reach a target weight. And we've decorated this with a description on line 12, as well as the parameter that gets passed in. And we perform some simple arithmetic to calculate that. So now that we've spoken about the memory component, the agent, and the client details model, we can see how all this gets wired together by looking at the program.cs file. And here we are in the program.cs file. So this is just a regular console application. And like before, we create our AI agent by passing in the options and name. What's different here, though, is compared to earlier examples, we now pass in an AIContextProvider factory, and that's what we can see here. Okay, we set the instance to be the client details memory, which is our memory component. And if we jump out into our client details memory component again, we can go back up here and look at the constructor. We take the chat client, any serialized state, and the serialized options, okay? But if we go back into here, we can see how these map. So we're just using the context. And that's basically all it takes to get that set up. We can look in at our chat loop, which is run chat loop with thread. And what's a little bit different here is that we capture like some events, such as if a person types save, we can manually serialize the memory along with the thread. And down here, we have a loop that just streams the response from the agent. If we scroll down a little bit further here, we can see we have our memory access code. So there's quite a few things going on, right? The best way to show this is to run it, right? So the first thing that we'll see is hi, and our agent has asked us what our current weight is. So before we supply this, okay, if we look up at the events in the square brackets here, we can see that our agent is trying to extract some content. We haven't answered any questions yet, so there's nothing to extract. So the methods invoking async and invoked async don't have any content to process, right? But as we work through each of the questions, these extraction events, invoking and invoked async in conjunction with the memory component, will start to build up. So we'll say the current weight is 85 kg and the events are fired, so that's invoking async and invoked async. So before extraction, there's nothing there. The extraction result, however, this time we have 85 kg as the current weight. We can supply our desired weight. And before we answer this, we can also see the agent memory contents in yellow at the bottom here are being filled out. The content there is actually being read back from memory. So we'll say 80 kg. And again, the events fire. After everything's updated, we now have the current weight, we have the desired weight. Our agent memory contents have been updated after all of the events have fired. And finally, remember, our client details model has three properties, which are name, current weight, and desired weight. We finally have to supply the name. Now that we have all pieces of information in memory, our agent's function tool gets called. We can see we are greeted by our name. The agent knows our current weight and our target weight. And using the function tool, it's identified when next year the target would be hit. If we move this over to the right, and if we go back into the program.cs, remember we track if a person inputs save. So we'll put a breakpoint here, and we'll input save. What we'll see here is the memory being serialized. And this is our serialized method that is overwritten. So we're taking our user info content that has been persisted in the memory component. Remember, this has been serialized and captured during the events invoking and invoked async. And we output this information to the console. I'll bring the console application back into view, and here we see our memory, or the serialized version of it. So just to recap, what we've seen here is how to create a memory component that persists between requests. We've seen events that you can override and subscribe to in terms of invoking and invoked async. We've seen how you can supplement those calls with data that is captured by your agent. And we've seen the events fire in real time as we've worked through an interaction. If you'd like to find out more information about all this things together, then you can read the accompanying blog at jamiemaguire.net.